Alright, in the last video we had the example of a product of two binomials and we had to multiply it out. So this time, what would happen if we just try to take the derivative of each piece? The derivative of x squared would be 2x. The derivative of 3x would be 3, so that would give us 6x. Now we know we can multiply this stuff out. Let's go d dx of x squared times 3x is 3x cubed, and so bring the exponent 3 down, multiply it to the coefficient 3, so we have 9x, and make that one less power, 9x squared. So what does that tell us about taking the derivative of each piece? It is wrong. Never, ever, ever do that. And that's what today's stuff is all about. We're going to be learning the product rule right now. The product rule, here's a standard way to write it with u and v being differentiable functions of x. I like to use this version. So we have fs, f stands for first, s stands for second. We have derivative of the first times the second plus the first times the derivative of the second. And that's what we're going to chant, and we're going to sing it in class. You could also use the f prime s, f prime. That's great when you're writing it, but when we say it, we'll say derivative of the first times the second plus the first times the derivative of the second. The reason why I like this one is if you have multiple terms in there, more than two, you could have 3 or 4, it doesn't really matter. Whatever term you're at, that's the one you take the derivative of. So we have the first term, derivative of the first, the second stays in the same spot. And then we leave the first alone, we take the derivative of the second one. And if we had a third, we could say plus first and second times the derivative of the third. And that is a nice way, and we need to know that. All right, let's go to the next page. All right, let's apply that product rule to this example. We have y equals this. The first thing I want to do is rewrite it. Just to make it a little bit easier, we'll say wasn't quite right in there, so 2x to the 1/2, and then 5x cubed, we'll leave that alone. So we're going to do this two ways just to show it. First, we'll use it without the product rule. So let's go ahead and multiply all this stuff out. So we'll get 3 times 5x cubed will give us 15x cubed minus 21 plus 10x to the 7/2 minus 14x to the 1/2. Now that's just y. We're going to find the derivative now. Let's find dy dx. 3 times 15 will give us 45 x squared plus that derivative of 21, that's a constant, so that'll just go to 0. It's not changing. And we have 10 times 7/2, that'll give us a 35, and x to the 1 less, 5/2, minus 14 times 1/2 is 7, times x to the negative 1/2. Now let's go and do it using the product rule. Again, I'm going to rewrite it. So we'll have 3 plus 2x to the 1/2 times that quantity of 5x cubed minus 7. So this time we have our first and our second. So on the other side, let's go ahead and just rewrite it. We have derivative of the first times the second plus the first times the derivative of the second. So dy dx equals derivative of this first parenthesis, the 2 times the 1/2 will just give us the 1, so it's x to the negative 1/2, that 1 less power, times 5x to the third, because all we're doing is copying down the second term, plus the first, we just copy it down, x to the 1/2. And then we take the derivative of that second one, we'll have 15x squared minus 0, so it's just that. Now, this is simple enough that I want you to simplify. When we do it in class, we'll show some really ugly ones, and at that point we're not going to simplify anything, but this is good. And we will also compare it and see, can we get it to look like the other one? So let's go ahead and multiply that out. We have 5x to the 5/2 minus 7x to the negative 1/2 plus 45x squared plus 30x to the 5/2. And then go ahead and combine our like terms and we will get, rearrange it, 45x squared plus 35x to the 5/2 minus 7x to the negative 1/2. Now let's see, yes, these are the same, which is what we need. All right, if it doesn't say how to do it, then it's your choice. You have to look at the situation, and what you want to do in general is just kind of see which one, as you do more of them, you'll see which one's easier to do in that setting. All right, the quotient rule. I like this version of the quotient rule. There, I moved it up a little bit. So again, we have u and v functions. We have our standard one right here, but I like to use t and b for top and bottom. So we have derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And we can also write it with the abbreviated notation using the primes. One thing I like about this is it's similar to the product rule if you're thinking about the first being the top and the second being the bottom, but there's a minus. Now, why should that make sense? If we think about x to the a divided by x to the b, you're going to have x to the a minus b. So it shouldn't come as a surprise that this is going to be a minus. But we're going to need to know this one. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. All right, let's go ahead and apply this. So we have this problem, the derivative of x divided by x squared plus 1. So the derivative of the top would just be 1 times the bottom minus the top times the derivative of the bottom. We have our 2x. If I could get that to show up there. There we go. There. And then all over the bottom squared. And then let's go ahead and simplify this. All right, so we have x squared plus 1 minus 2x squared all over x squared plus 1 quantity squared. And then that gives us 1 minus x squared over x squared plus 1 quantity squared. Now, you want to look at this and see, can you simplify this at all? And in this situation, we have 1 minus x, 1 plus x, and this bottom one can't be factored anymore, so we're done with that. All right, let's look at the next one. What I'd strongly suggest you do is pause it, do it yourself, and then go ahead and check. All right, we have 10x, the derivative of the top, times the bottom, just copy that thing over, minus the top, 5x squared, times the derivative of the bottom, 3x squared, all divided by x cubed plus 1 squared. And at this point, it's just simplification, so it's just doing your algebra. So we have 10x to the 4th plus 10x minus 15x to the 4th divided by that same quantity, x cubed plus 1 quantity squared. And let's combine our like terms. So we have negative 5x to the 4th plus 10x divided by that quantity x cubed plus 1 squared. And you always want to think, can I factor this? I can pull out the 5x, but then I'm going to have a minus still in the top, and I'm not going to be able to simplify that with what I have here. All right, let's go on to the next page. Now we're talking about taking derivatives. And when you're looking at taking a derivative, you have your notation dy dx or y prime. There's also a second derivative, which you could say is y double prime or d squared y dx squared. The second derivative is an example of a higher order derivative, and you can continue this. So we have y prime, y double prime, y triple prime. Now the second derivative is a derivative of the first derivative. The third derivative is the derivative of the second derivative, or you could say it is the derivative of the derivative of the derivative. So you could keep on going in this way. There's another way to write it that you'll see it, and it'll be d sub x of x. Now I don't tend to use that notation, but it is valid and it's perfectly fine. After you start getting past the third derivative, you typically just write it in parentheses, so whatever number. The nth derivative would be in parentheses n there. There's one thing is interesting to note in terms of derivative is Newton, when he created calculus, he was afraid of somebody stealing his notes. So what he did is he created his own notation. That way if anybody got his notes, they wouldn't have any clue as to what he was doing. Let's apply this to this problem. So what this is telling us here is that we're asked for the fourth derivative of this expression. Now, to save us a little bit, let's define this as being y. So then what we're going to be finding is the fourth derivative of y. We just need to write it out and go through it step by step. So the first derivative is, we're just going to use the product rule over and over again. So we have negative 40 x to the 7th plus 12x to the 5th minus 27x squared plus 32. And that constant's going to 0. Now we're going to find the second derivative, and that's the derivative of the derivative. So we'll bring down that 7, we get negative 280x to the 6th plus 60x to the 4th minus 54x, and then the derivative of that constant 32 again is 0. Let's go the next one, the third derivative, and we'll go 6 times 280. Good chance to practice your mental math. Negative 1680x to the 5th plus 240x cubed minus 54. And now we're getting to what we're actually asked for, the fourth derivative. And that will give us negative 8400x to the 4th plus 720x squared. And again, the derivative of that constant is 0. So one thing it's interesting to note, when we're finding that fourth derivative, notice these original terms. So we had 5, and now we're ending up with 2. These 3 are going to end up going to 0 because eventually there'll be a constant, and the derivative of that constant is 0. We still need to show all the work in each step, but that is something you can keep in mind. All right, let's come to this next one. So we're going to take the second derivative here of this function. So let's just go through, and we're going to have to apply the quotient rule. So we have f prime, derivative of the top is 1 times the bottom, x minus 1 minus the top times the derivative of the bottom 1 all over the bottom squared. We simplify that and get negative 1 over x minus 1 squared. Now we're going to find the derivative of this, so we'll need the derivative of the bottom, but we don't know how to deal with this thing yet. We'll learn that later. So right now what we need to do is just multiply that out. So we have x minus 1 squared is going to give us our x squared minus 2x plus 1. Let's come over here and we'll say our second derivative is derivative of the top. Now that's a constant, so it's just 0, times the bottom. And in this situation, I'm just going to go ahead and write it in its compact form. Minus the top, negative 1, times the derivative of the bottom, but that one I'm going to use this form. Since I know how to take the derivative of that, that'll give us our 2x minus 2, all divided by the denominator, the bottom squared. So we'll have to the 4th power. And at this point, we just need to simplify everything. If you do this, I could have written it all out. This one's going to have the negative 2x plus 1. And so the negative 2x part, because this is just going to be a positive now, is going to go away. And so we'll end up being left with 2. Oh, sorry. Let's hit. So now we just need to simplify this, but this is 0, so we just have 2x minus 2 over the quantity of x minus 1 to the 4th. That can be written as 2 times the quantity of x minus 1, so we have x minus 1 to the 4th, and then we can reduce that. So our final answer will be 2 times, or 2 divided by the quantity of x minus 1 cubed. All right, one last problem here. We're given the 4th derivative equals 2 root x. So I want to rewrite that right now so I can see that a little better. 2 to the times x to the 1/2, and we're asked to find the 5th derivative. Well, the 5th is just one more derivative from there, so we can just write the 5th derivative is the derivative of this. 2 times 1/2 would just be 1 times x, and then 1/2 minus 1 gives us negative 1/2. Or, you don't have to, but or you could write it as 1 over root x. And that is it. So we have our power rule, we have our product rule, and we have our quotient rule. Write the following down in your notes here. If you have two functions, you must apply the product rule, not just multiply. That's something we have to know. You can check, let's say you forget what it was, check with a simple example. You can do something like x times x and then work that out. But so what you've written, remember you have to, if you have two functions, you must apply the product rule. And that is it.